I have a story to tell, a fairy tale. Once upon a time, many years ago, a child was born who was loved by no one but her father, and was hated and ridiculed by everybody else. And then her father died. Like all good stories, there has to be an element of tragedy. And she was left to make her own way in the world. But eventually she grew up into a beautiful princess who was loved and respected by all, and her beauty has never faded since. So really, I think you should stay with me to find out why this girl was so hated and what caused her to grow up into the beautiful princess who everybody eventually adored. So let's go back in time a little bit. It's a cold, freezing day, the 6th of January 1912. We're in Frankfurt, Germany, and a scientist is on his way to present a scientific paper to the German Geological Society. He was quite a young man at the time, 32, and he was nervous, for the lecture theatre was going to be full of some of the most clever and experienced geologists at the top of the game. And he was also very aware that he was working outside his field of expertise, because he was a meteorologist, and he had a PhD in astrophysics. And he was going to present a paper on a particular geological subject, and geology wasn't his thing. The learned men at that day's meeting sniffed at this mad theory. Later that year, he joined an expedition to Greenland, and then he got sucked up into the horrors of World War I. However, in spite of all the expeditions and wars, he published in 1915 a book called The Origins of Continents and Oceans in his native German. Now, this book languished unnoticed by the geological community, thanks partly due to the ongoing conflict that lasted until 1918, and the fact that it was written in German, which made it inaccessible to English-speaking geologists. However, an English-speaking translation came out in 1924, and the earth sciences have never been the same since. It might seem self-evident today, but the theory of continental drift, as the new theory was dubbed, was extremely controversial, and it took decades of debate, academic fighting, and hard work before the mechanisms were fully understood. But when the mechanisms were finally bolted down, it really was a eureka moment for the earth sciences. It was indeed the grand unified theory of geology, and it is through this lens that we're now able to view and understand our physical world. So the landscape, the ocean basins, earthquakes, volcanoes, tsunamis, and climate are all enthralled, are all controlled by plate tectonics. So without plate tectonics, Earth would be a dead and lifeless place. It would also be flat and boring, and we as a species would probably not be here, along with all the other species on the planet. So stick around to find out why. So the story I'm telling you is one full of drama. We've already had tragedy. We've already had the orphaned princess. But it's also about academic infighting, academic bullying, bravery, creativity, and sheer hard work. And eventually a lot of money was thrown at it too. So we've all seen footage of volcanoes throwing towering, billowing columns of hot ash high into the sky. And we've seen tsunamis roll relentlessly and destructively across the landscape, and held our breaths as people ran for their lives, urging them to get to the staircase before they're engulfed by the rising waters. And we've seen those cars speeding along the roads, and there in the distance we see those waves rolling across the landscape to eventually catch them. And there was all sorts of untold destruction and death. And we saw the Fukushima power station get inundated with seawater, a problem which they're living with to this day. So we understand that tsunamis are due to shifts in tectonic plates, and that earthquakes are also related to movement along plate boundaries. The link with volcanoes is perhaps a little bit more tenuous in our thinking. Although these disasters make the news and are directly attributable to movements along plate boundaries, our physical world has been created due to plate tectonics and has constantly been modified by processes that are either directly attributable to them or as a result of changes to the landscape which affect us in more subtle ways. It was Abraham Ortelius, essentially from the Netherlands, who was at the time the world's first map maker, who noticed the similarities of the shape of the African and South American coasts back in the 16th century, when maps became sufficiently accurate for these kinds of comparisons to be made. And then later, Antonio Snyder Pellegrini, in 1855, noticed the similarity between the coastlines of South America and Africa, and actually ventured a reconstruction of the continents. Then Roberto Montavani, an Italian geologist, wrote papers on continental drift in 1889 and in 1909, supporting an expanding Earth hypothesis to account for the ocean basins. Also around the same time, Frank B. Taylor, an American geologist, which brings us back to our famous meteorologist and his controversial new theory that he cheekily put forward in his book, The Origins of Continents and Oceans, which we saw earlier. And so it's time to reveal his identity. His name was Alfred Wegener, and he is widely acknowledged as the father of the theory of continental drift and plate tectonics. An ugly child which no one wanted. He had become interested in the topic in 1911 when he had accidentally come across a paper describing fossils of identical plants and animals on opposite sides of the Atlantic. And this piqued his interest in the subjects, and he ultimately led to his 1912 paper, which we saw earlier, and then his 1915 book, which eventually was published in English in 1922. The 1922 English version drew a great deal of flack from geologists in Britain and America. One also needs to acknowledge that some of the hostility may have also been due to anti-German feelings thanks to the long and bitter conflict of World War I. Also, he was treading on the toes of the geologist, being a meteorologist. And possibly also because he couldn't come up with a mechanism for how the continents did drift. And the whole idea just seems so totally absurd. But Wegener was an exceptionally clever man, who along with his father-in-law had written the book, the leading book at the time on climatology. To this day, Vladimir Kurpin and Alfred Wegener's book is available, and Kurpin is still respected in meteorological circles. Wegener was also not a man who sat around inventing armchair theories. He went off on his expedition in 1912 and he acquired scientific data, and he led subsequent expeditions to Greenland to measure thicknesses of Arctic ice and to carry out state-of-the-art experiments and meteorological studies. He was also well versed in paleobotany and paleontology, and was well aware that Permian-aged coalfields were to be found in Africa, Australia, South America, Madagascar, India, and Antarctica. And furthermore, a fossil dicynodont called Lystrosaurus was found in India, Antarctica, and South Africa. And finally, a fossil freshwater reptile called Mesosaurus was found only in South Africa and Brazil. Previous theories had been that the continents had been joined together by land bridges that had sunk into the Atlantic Ocean. But it was Wegener who came up with this idea, based on his field observations, fossil evidence, and his reading, that the continents at one stage were joined together to form a supercontinent, which he called Pangaea. Little did he realize that his big idea, and it certainly was a big idea, would meet with so much hostility, and that hostility would continue to erupt for over half a century. For example, a year after the first English translation of Wegener's book, Philip Lake, who was then professor of geography at Cambridge and also quite a famous and accomplished geologist, had this to say at a meeting of the Royal Geographical Society. He is not seeking the truth. He is advocating a cause and is blind to every fact and argument that tells against it, It is easy to fit the pieces of a puzzle together if you distort their shape, and when you have done so, your success is no proof that you have placed them in their original positions. It is not even a proof that the pieces belong to the same puzzle or that all the pieces are present. Ouch. Not mincing his words, William Scott, geology professor at Princeton, said, "Utter damned rot." And Edward Berry, an American paleobotanist, called Wegener's theory a selective search through the literature, this is a goodie, for corroborative evidence, ignoring most of the facts that are opposed to the idea and ending in a state of auto-intoxication. Whatever you might say about Berry, he certainly had a way with words. Wegener tragically died in a Greenland blizzard in 1930 on his 50th birthday, or maybe the day after, no one's quite sure. And his theory was orphaned, having to grow up in a hostile world without any real guardians to see her through to adulthood. But there were some supporters. All brave men, in view of the attacks that had made on the theory. The names shall forever be written in the halls of geological fame, namely Alexander du Toit, Arthur Holmes, and Reginald Daly. Now, Reginald Daly was a Canadian who headed Harvard's geology department and who was a renowned field geologist with a passionate interest in basalt. "No rock type is more important on Earth," he said. So he recognized that ocean crust comprised heavy basalt, whilst the continents were made mostly of lighter granite. So quite early on, Daly agreed with continental drift and supported the idea with data he personally gathered around the world. And then there's Alex du Toit. So du Toit was a South African geologist, considered by many to be the greatest field geologist of them all. He spent much of his life mapping the geology of South Africa, from the ancient granite basement up through the entire sedimentary pile that makes up the Karoo supergroup to the basaltic lavas that form the high plateau of the Drakensberg. He did this almost single-handedly. In the days before satellite imagery, in the days before aerophotographs, in the days before GPS. So he didn't even have topographic maps to put his geology onto. He had to make his own maps before he could even get that far. So du Toit could not deny the evidence. The late Carboniferous to early Permian aged glacial deposits of the Dwicker group, the Lystrosaurus fossils, the Mesosaurus fossils, the Sinognathus fossils that were found across what we now know as the Gondwana continents, namely Africa, India, South America and Australia, and of course Antarctica, and the presence of those pesky Permian coalfields with their dominant Glossopteris flora. So, seeking more evidence, du Toit travelled to South America on a Carnegie Institution grant to inspect the geology, which according to his theory would have been joined together more than 200 million years before. So he published a paper on his South American travels called A Geological Comparison of South America with South Africa in 1927. And then 10 years later, he published a seminal book called Our Wandering Continents, which pulled all the evidence together to support the continental drift hypothesis. It was a brave move on his part, considering the hostility of our European and American geologists, who were not particularly open to such silly ideas, and had, of course, made their thoughts forcefully clear on the matter. 2 years later, World War II breaks out, and perhaps the focus of the world, including that of the geologists, went elsewhere, allowing the theory to mature while battles were fought elsewhere. And then there was Arthur Holmes. Now, he was a very influential and brilliant British geologist who developed a way to measure the age of the Earth using radioactive decay. He was the first to propose that the Earth was over 1 billion years old, which flew in the face of the maximum date that was given by Lord Kelvin. Kelvin was the leading physicist of the day, and no one ever dared to challenge him. Holmes then figured out the mechanics of mantle convection and claimed that he had found the power source needed to make the continents drift. He also drew extensively on the work of du Toit and Wegener when presenting the evidence for continental drift in his book Principles of Physical Geology. So that book was read by many generations of students, with the younger generations perhaps more open to the new theories supporting the continental drift hypothesis. I have a copy of Holmes's book, The Principles of Physical Geology. Arthur Holmes. But it is a fascinating read because it's written before the wide acceptance of plate tectonics. It has all sorts of interesting speculative diagrams about the reason for the shape of the ocean basins, why earthquakes and volcanoes were concentrated where they are. One can see the reaching, some at the time would say overreaching, for an answer to the questions that had bothered earth scientists for decades, with a quest viewed partially through a foggy lens that Wegener had left behind for his disbelieving geologist counterparts. So the final chapter of Holmes's 1944 edition is about the mobility of the Earth's crust. It has the first ever drawing of mantle convection and includes the lines. Currents flowing horizontally between the crust would inevitably carry the continents along with them. That was pure genius, but a very brave move back then. So World War II dragged on for 6 long years. At the end of it, everybody was deeply affected by the waste of human life, resources and effort. But out of that madness, for the earth sciences at least, came some degree of consolation. Captain Harry Hess of the United States Navy, skipper of the USS Cape Johnson, had made voyages across the Pacific on submarine patrols during the war. So his ship was equipped with sonar and an echo sounder. And Hess, having come from a geophysical background, kept his equipment running even when he wasn't looking for submarines. And thanks to that unplanned and unsolicited wartime surveying exercise, he was able to collect ocean floor profiles across the northern Pacific. And that data was crucial in latter years at Princeton in supporting the continental drift hypothesis. And then in the 1950s, Ron Mason of Imperial College, London, working at the Scripps Institute of Oceanography, managed to convince the US Navy to allow him to tow a flux gate magnetometer developed by Victor Vacquier behind one of their ships to try and understand the geophysical nature of the ocean floor. Well, the US Navy agreed to that, and the survey showed that there were reversals of the magnetic signature of the basalts that made up the ocean floor. No one worked out what these things meant, least of all Mason. And so he went off to work on another project, and he was to kick himself later for that. It's a basalt, which is an extrusive igneous rock, a lava. Contains a mineral called magnetite. So when the lava is still in its liquid state, that magnetite orientates itself to the magnetic North Pole. And then as the magma cools, it passes through what is called the Curie point, and the orientation of those magnetite crystals are locked in to the basalt. It's like putting a magnetized needle on a piece of cork, floating it in a bowl of water and sticking it in the freezer. So when the water freezes and turns into ice, the cork with its magnetized needle are frozen in, and we know what direction North Pole was when freezing point was reached. So the reversals of the magnetic signature of the ocean floor, as recorded by Mason, first thought to be anomalous, until Drummond Matthews and Frederick Vine of Cambridge University realized the significance of these zebra patterns. In a 1963 paper, they put forward the theory that new oceanic crust was being created at the mid-oceanic ridges, which ran as a continuous range of mountains thousands of kilometers throughout all the ocean basins, with newer crust being located closest to the spreading centers and older crust being found further away. So when a magnetic reversal took place, this was recorded in new orientations of the magnetite in the newly emplaced basaltic lavas, parallel to the spreading centers, with older reversals located further away from the center. The real kicker here is that the reversals were mirrored either side of the spreading center. It was like having two conveyor belts laid end to end, carrying newly added material away from the common center at a constant speed. And so, strangely enough, Lorenz Morning, a Canadian geologist, had written a paper a year earlier than Matthews and Vine, in which he put forward exactly the same idea. But this paper was turned down by Nature, one of the leading scientific journals of the time, and still is. And so he had to publish in a more obscure journal which no one read. So Matthews and Vine got the glory. But geologists are sporting chaps. That's girls included. And so the theory is now known as the Morning, Matthews and Vine theory. And it was fundamental in bolting down the mechanisms of plate tectonics. Ron Mason is almost forgotten, which is a pity. And Wegener, unless you go looking in the literature, is also forgotten. And he was the one who invented this magnetometer that allowed all this work to take place. He was born in Russia and had escaped the Bolshevik Revolution. So Earth scientists were now forced to take heed of Wegener's crackpot theory, for it was the only way to explain away the geophysical data. And to help them was Holmes's work and the physical evidence in terms of fossils, flora and rock types supplied by Dutoit and Daly. Additional geophysical work confirmed the location of the subduction zones along the destructive plate margins, most notably by Hugo Benioff, who discovered a planar zone of seismicity, which corresponded with the sinking slab and subduction zones. Some of those earthquakes extending to 670 kilometers depth. And then in the early 1960s, Edward Bullard from Cambridge used a computer to fit all the continents together. So instead of using the current shorelines, as other geophysicists had previously done, he used a depth of 914 meters, 3,000 feet below sea level. So that depth corresponds more or less to about halfway between the shoreline and the ocean basins and represents more accurately the edge of the continents. By doing so, he discovered a near perfect fit of the African and South American shorelines. And girls, this one's for you. Mari Tharp, a map maker and seismologist, began to put together all the data into a map of the ocean basins and made the claim that her maps confirmed continental drift theory. So her ideas were met with hostility, but eventually she got the support which she needed to make the map the ocean floors, which we are familiar with now. So in a male-dominated world, she battled to find a space, but eventually attitudes did change, and she made a mark and was recognized and awarded for her work. So well done. The world is a different place. Maybe we can thank Wegener. So once the theory of plate tectonics was widely accepted by the earth science community, it was heady days indeed. Suddenly geologists saw the world through the lens that Wegener had left them. And boy, what a wonderful view. What a wonderful view that was. And no one had the heart or the academic authority to scoff at these ideas. In the US, which had been so anti these mad ideas, geologists became fanatical converts, embracing the new theory with a fervor equal to their contempt thereof. Another US, having deep pockets, financed a deep-sea drilling program to explore the ocean. And a ship called the Glomar Challenger, which was a deep-sea and scientific research vessel, designed specifically for oceanography and marine geology studies, was built for this purpose. So the name was a nod to HMS Challenger, which had made the first oceanographic studies back in 1875 and had sounded the Marianas Trench, the Challenger Deep. So little did the HMS Challenger crew realize when they were taking that historical sounding that they were recording the deepest point on Earth. So starting in August 1968, the Glomar Challenger embarked on a 15-year-long scientific expedition the deep sea drilling program. And they crisscrossed the mid-Atlantic ridge between South America and Africa and drilled core samples at specific locations. And the age of those samples was determined by paleontological and isotopic dating studies, providing conclusive evidence for seafloor spreading and continental drift, now more correctly known as plate tectonics. It's interesting to note that no oceanic crust has been found to be older than 200 million years, which further supported the plate tectonic hypothesis. So at the end of it, Wegener's orphan was now a beautiful princess with the world at her feet. So by 1965, almost everyone was a convert to plate tectonics. And scientists, geologists began to examine not only the oceans and the positions of the continents through Wegener's lens, but the entire discipline. Suddenly everything was crystal clear. And it was exciting times indeed to be involved in the earth sciences. So now we have a mechanism to explain the Alps, the Rockies, the Andes, and the mightiest of them all, the Himalaya. Volcanoes along the west coast of the US, volcanoes in Japan and Indonesia can be explained in the light of the new paradigm. The San Andreas Fault and all those earthquakes there, famous for demolishing San Francisco and Los Angeles on a regular basis, can be explained away. The San Andreas Fault is a surface manifestation of a transform fault, which Tuzo Wilson, a Canadian geologist, also worked out. And he was also fundamental in this whole study of continental drift and plate tectonics. The flora, fauna, and identical rock types of all the Gondwana continents could now be easily explained away without having to invoke crazy notions of land bridges and sunken continents. So the mountains of the Cape, some 300 million years old, are the product of continental collision. And the High Drakensberg, comprising flat basalts, are a result of underplating and uplift due to hotspots under southern Africa, which led to the breakup of Gondwana due to continental rifting. Suddenly it all made sense. So plate tectonics explain the formation of mountains and oceans, mineral deposits and coal fields, earthquakes and tsunamis, and it was revolutionary. And nothing in the earth sciences was untouched by the new theory. And so we've come to the end of the grand tale of big science, big battles and big egos. And we've seen our orphan grow up into a beautiful princess, which now everybody loves. And so we cannot look at the world without seeing it through the lens of plate tectonics. So when we talk about geomorphology, hard rock and soft rock, waterfalls, nick points, base levels, ocean basins, all of these things, it has to be seen through that lens. It has to be seen through that lens of plate tectonics, because plate tectonics creates our world. Taking things a little further, climatology is enthralled to the topography, which is again deeply influenced by geology. Orographic rain falls along the southern Cape Coast in places like Georgia and Neisner, but on the other side of the Outeniqua Range, in the Little Karoo, and in the towns of Oudtshoorn and the like, it was a different situation altogether, where it's semi-desert. This is in sharp contrast to the lush vegetation along the coastal belt. The KZN Midlands, at altitudes of well over 1,000 meters, has a very different climate, for instance, to the coastal regions a short 100-kilometer drive away. And really stepping out now, this is really stepping out. And papers have been written on this, but there's a theory that the evolution of humans, hominins, on the plains of East Africa was also due to environmental pressures imposed by climate change due to the uplift of the Tibetan Plateau as the result of the collision of India with Asia. So this massive heat sink created huge convection currents which stole the monsoon rains, which normally had fallen on East Africa. So this reduction in monsoonal rains led to the aridification of East Africa and the development of vast grasslands. So at the same time, the East African Rift Valley began to form due to a mantle plume developing below the East African region, which pushed the land up to elevations in excess of 3,000 meters, along with the development of deep lakes and the rifts that form between the highlands due to tensional forces playing out in the Earth's crust. And in that dynamic environment of rifting, climate change, and cyclical filling and drying out of the lakes, our ancestors had to make a living, abandoning their forest life because the forests were essentially disappearing, and adopting bipedalism and evolving a larger brain to ensure their survival out on the vast African savanna. So none of us are untouched by plate tectonics. As I said earlier, we might not be here if it wasn't for plate tectonics. It's fundamental to the operating systems of the planet. We must leave it there. This has been a story of an orphan who grew into a beautiful princess with a world at her feet. It's a story that inspired big science and which changed the way we see the world and our place in it. It is a story that led to the understanding of the workings of the planet and an understanding of earthquakes and volcanic eruptions, formation of ore bodies and mountains. And in that story, we're able to understand the processes that lead to the development of the landscape and how those landscapes have affected us in terms of our evolutionary past and how they will continue to affect us for as long as we have a human future. Thank you.